Hey everyone, welcome to Mindful Math, and today we're going to talk about standardized test questions. Everybody's favorite. Teachers love standardized tests. They love that they have these high stakes tests that measure students' ability off of one test and how well they taught things, even though oftentimes the questions are very different from what we really want students to learn and what we really teach in math class. So one of the things about standardized tests is that there tend to be multiple choice. And that is a bit different than most math tests that you take in school. So usually we want to show as much work as possible, show our thought process, and how we arrived at that answer, at our answer. And that's great, and that is definitely something that we here at Mindful Math like, because we want mindfulness. We're much more about the process than we are the end result. But I actually think that there is something useful to using multiple choice answers and doing things a little bit differently. So anytime we can do a problem in a new way, it almost automatically increases mindfulness and increases our understanding of things. So since we usually don't have multiple choice answers, we do have to do things the long way. I want to show you ways that we can actually use the answer choices in test questions, in standardized test questions, to our advantage. And hopefully that allows you to see a connection between how you normally do things in math class and the standardized test questions, and allows you to see things in a slightly different way and hopefully boost your understanding. So let's take a look at two standardized test questions. So I got these from the state of California. I don't think they're that different than any other state, but let's go ahead and take a look. So these are Algebra 1 standardized test questions. So the first question is, Marcy has a total of 100 dimes and quarters. If the value is $14.05, how many quarters does she have? So the first thing we want to do on any standardized test question is identify the actual question. So just keep in mind, this question could have easily asked how many dimes does she have. There's really no difference in terms of the math, but we do want to be careful and say we are looking for the number of quarters. All right. So one way to do this problem, in the way that you would have been taught in your Algebra 1 courses, would be to set up a system of equations and say quarters plus dimes equals 100, and 0.25 Q plus 0.1 D equals $14.05. So certainly nothing wrong with that. That will give you the right answer. But the other thing that we can do, since we're given answer choices, we know that the number of quarters either has to be 27, 40, 56, or 73. So we actually can just go in reverse and use the answer choices and plug them into the equation. So when we do this, we always want to pick, if it's 4, we want to pick B or C. If it's 5, it's actually a little more complicated, and maybe I'll talk about that another time. But we want to pick these because we know that if we pick 40 and the number of quarters is too high, we don't even have to check 27. We know that that has to be the right answer because it's the only one left that can work. Conversely, if we pick 56 and it's too low, we could pick answer choice 73, knowing that it's right without even checking the work. So let's go ahead and do it. We'll pick choice C just for... Actually, you know what? I'm going to change my mind. I was going to pick choice C just because I happen to know the correct answer to this one. But we should pick choice B because 40 is an easier number to work with than 56. So again, using anything to your advantage here, it's easier to multiply by 40 than it is to multiply by 56. So hopefully you stay mindful. I was trying to illustrate a point, but I think actually illustrating this mindfulness point is more important. So if we plug it in, again, we're looking for the number of quarters, not the number of dimes. So if we have 40 quarters, we multiply that by 0.25, and we'll then have 60 dimes, and we'll multiply that by 0.1. And hopefully you're allowed a calculator on your test, but if not, you could probably do this. So this would give us 40 times 0.25, which is 40 divided by 4 is 10. And this would give us 60 times 0.1, which is just 6. And that equals 16, which we know is too much because we wanted it to be $14.05. So we would know that it's answer choice A, and if you were taking a standardized test with time pressure, you should pick A without even checking it, because you know that 40 is too high. The answer has to be 27. For the sake of completeness, let's go ahead and show that this method does work. And if we have 27 quarters, we have 27 times 0.25 plus 73 times 0.1. And 27 times 0.25, one way you could do that, 28 times 0.25 would be 7, so we're going to have 6.75, just because it's 1/4 less than 7. And of course, 73 times 0.1 is 7.3. If we add those together, we get 13 plus 1.05, which is 1405, and we arrive at the right answer. So, when your answer choices are numbers, and the question we're being asked is a variable. So the question we were asked was, how many quarters does Marcy have? When we're asked that, we can use these numbers in the answer choices and plug them in. All right, let's go ahead and look at a different kind of standardized test problem that you'll see a lot of. And that is when you have variables in the question and variables in the answer choices. So in this case, we certainly can't plug in our answer choices, but we can do a different technique, which is picking numbers. So numbers are a lot easier to work with than variables. And when we have variables in our answer choices, oftentimes we can pick numbers and check to see which ones are equal. So we have that 5x cubed over 10x to the 7th equals what? And we need it to equal one of these four answer choices. So if these two are equal, they'll be equal for all x's, no matter what x is, except x can't be 0 in this case, but no matter what x is, it will have to equal the answer choice that we pick. So we actually can pick a number for x, and if it isn't equal to the answer choice in that given number, we know that that answer choice is wrong. So this technique can sometimes give us more than one possible answer, but oftentimes it will allow us to eliminate all of the answers, or at least will get us down to 2, and then we can just pick another number. So you could certainly approach this from an algebraic perspective and simplify everything, but another way to do it is say, okay, let's test what happens when x equals 1. When x is 1, we have 5, 1 to the 3rd, over 10, 1 to the 7th. And you'll notice I pick an easy number, x is 1, to calculate. So in this case, 1 to the 3rd is 1, so we have 5 over 10, and that equals 1/2. So now we can plug in 1 into our answer choices and see which ones give us 1/2. If it doesn't give us 1/2, we know that it's not equal to this because it has to be equal no matter what x is. So if it's not equal when x equals 1, boom, not the right answer. So when x equals 1, a is 2 times 1, a is no good. When x equals 1 for b, we have 1 over 2 x to the 4th, which is 1/2. That might be good. We do still need to check every problem because it's possible that we have more than one answer choice that will be correct when x equals 1. So for c, we have 1 over 5. That's no good. And for d, we again have 1 over 5. Also no good. So we know that B is our correct answer choice. And most of the time, I think, most of the time, if you pick a number like 1, and usually pick numbers like 1 and 0 or 2 that are easy to work with, you will find that you usually only have one answer choice that's correct. If you pick 0, you might be more likely to get more than one answer choice that could be correct. So maybe picking 1 or 2 is the best way to go if you're not sure. But the best way is actually to be mindful about it and think about what is going to eliminate the most answer choices. So this saves us the problem of having to solve this algebraically or having to memorize those exponent rules that we talked about in another video. So picking numbers when there are answer choices with variables can be very helpful. So that's just 2 ways that we can approach standardized test problems a little bit differently than we approach problems in math class. And I think anytime we can approach problems in more than one way, it helps us out. So if you know exponent rules and exponent rules are real easy for you and you go, nope, boom, I eliminate the x cubes, I get 1/2 over x to the 4th, that's fine. You can get to answer choice B quicker that way, approach it that way. If you're not sure on your exponent rules and you're going, oh man, do I subtract, do I add, do I divide, what do I do here? That's when you can use picking numbers. And in both of these cases, you should be able to do these problems a lot quicker than I demonstrated here, and there are a lot more shortcuts that you can use. So the more practice you get using them, the more comfortable you'll be. So I hope you enjoyed this video. I hope you try to approach problems in as many ways as possible, and we'll see you next time.